Hi students, this is Mr. Yao. Today we're going to continue to learn more different types of quadratic story problems. In the previous lesson, everything that we have solved for was setting up a quadratic equation, and then we were solving the variable in the equation. For this lesson, things are going to be a bit different. All the examples we're going to have in this lesson is not exactly solving equations, they're going to be asking for maximum. And that means in order to find the maximum, we're not solving equation, we are actually finding the vertex. Because that's where we actually have the maximum value for a quadratic function. We're finding the vertex, which in other words, we have to set up the function so that we can use negative b over 2a to find the vertex. So let's have a look. Example 1. Mike is putting a fence around the rectangular garden and has 52 feet of fencing to use. What should the dimensions of the garden be to maximize the area of the garden, and what is the maximum area? Well, if you remember in the previous lesson, I did say, even though in some questions you feel like there are two variables you need to set, in this case, for example, dimensions, which means you actually have a length and a width. Even though you have two variables, you have to get it down to one variable, which means you have to decide which one you're going to keep and then use that variable to present the other one so that you can actually set up a function or an equation. So in this case, the information given, 52 feet of fencing. And fencing is actually around a rectangle, which in other words, the 52 feet is the perimeter. Well, let's pretend we do have a length and a width. Well, the perimeter is 52. That actually equals 2 length and 2 width. That's how we calculate the perimeter of a rectangle. However, we can't have both variables when we try to set up a function, so a quadratic function, to be able to maximize it. So we have to decide which variable we want to keep. Let's say we actually want to keep the width. If we want to keep the width, that means we need to be able to find out what is the length in terms of width. So in other words, we are solving for L. Let's do that. We're going to subtract the 2w over to the other side. So 2L equals 52 minus 2w. And then we're going to divide both sides by 2. So my length is actually 52 over 2 is a 26 minus 2w over 2 is a w. So that is how we have represented the length using width. Now I can set up the function to represent the area, because that is what we're trying to maximize. We're trying to maximize the area. And it's going to be a function on the width. So it's a of w. In order to calculate the area, it is length, well, it's length times width. We have to represent the length using the width. So it's 26 minus w times w. That is how we calculate the area. We don't know what it equals to because this is the function and we're trying to maximize it. We don't have an equation that we can solve. So let's open the parentheses. Negative w squared plus 26 and w. And we're trying to find the maximum value for the function, which in other words, we're trying to find the y value for the vertex. And the x values would actually be the dimensions because, it's the width. And then after we find that, we can calculate the area, which is going to give us the maximized area. So let's start with finding the x value for the vertex. The width to be able to be maximized is going to be negative b over 2a, which in this case is a negative. My b is 26 over 2 times my a is a negative 1. It's negative 26 over negative 2, which is 13. So that means in order to maximize my area, I need my width to be 13 feet. So that is the x value, and in order to find the dimensions, I also need to find the length. So the length is 26 minus w, which is 26 minus 13, which is 13 feet as well. So now you see, even though it says a rectangle, well, a square is also a rectangle. So in fact, the maximized area is going to be a square. So now I can actually find, I know it's a 13 by 13. These are my dimensions. And the maximized area, you can either do 13 times 13, or you can plug 13 back in, is negative 13 squared plus 26 times 13, which is going to be 169 feet squared. And that is a maximized area. So you see it's a bit different than the previous lesson because we're setting up the function. Since we're maximizing, we're going to need to find the vertex. And of course, negative e over 2a is going to give us in this question the dimensions, which is the variable, the independent variable, which is width. And then we're going to use that to plug back into the function to find the actual maximized area. That's example 1. Moving on, example 2. Similar, you have a 1,200-foot row of fencing and a large field. You want to make 2 paddocks by splitting a rectangular enclosure in half. Well, here's what it means. A rectangular enclosure, but when you're splitting it in half, that means you're adding another layer of fence in the middle. What are the dimensions of the largest such enclosure? And you're using 1,200-foot row of fencing. So basically, these are all the fencing that you actually need. So randomly, you actually have a length, another length, a width, and another width. So in the previous example, you only have these, so it's going to be 2L and 2W. But for this one, since you have one thing to split in the middle, well, you actually have an extra width. Some of you might be like, well, how do you know it's going to be an extra width? What if you actually split the other way, that you're going to get an extra length? It actually doesn't matter because eventually you're going to find both dimensions anyway. So you just need 2 letters to present. And it is going to give you one number that is going this way and another number that's going horizontal. So they're actually going to be, they're going to give you the pair of answers anyway. So now let's set up. 1,200 is going to be, in this case, 2 of the length and 3 of the width. Let's say we still want to use width to set up our function. That means we're going to need to find out what is L, or in other words, solve for L using W. So use W to present L. If you subtract, so 2L, if you subtract the 3W over, is 1,200 minus 3W. Then divide both sides by 2. My L is going to be 600 minus 3/2 W. There you go. Now I have represented my length. I can calculate the area because we're trying to get the largest such enclosure. So we're trying to maximize the area. So the area is going to be a function on the width. And its length times width, in this case, is going to be 600 minus 3/2 W times W. Nothing else. Okay, let's open the parentheses. Going to be negative 3/2 W squared plus 600 W. We're trying to maximize that area again, so let's find the width to be able to maximize the area, which is negative e over 2a. My b is 600. My a is 2 times negative 3/2. So that's going to be a negative 600 on the top, and on the bottom is a negative 3. So to be able to maximize the area, the width has to be 200. Now I can also find my length, which is right here. It's going to be 600 minus 3/2 W. There's 600. Well, let me actually replace that W with 200. So it's 600 minus 300. The length is going to be 300. If you actually want to check, well, that's going to be 200 here, 200 here, another 200. And the width is actually 300. So in total, the width together is 600. The length together is also 600. So altogether, that is 1,200 foot of fencing. Okay. And lastly, we can actually find the maximized area if the question asks you for it. Otherwise, now you can already answer the question. It's going to be a 200 by 300. These are the dimensions. If the question does ask you for the area, you can either directly do 200 times 300, or you can choose to plug back in the 200, negative 3/2 times 200 squared plus 600 times 200. No matter which way, it's going to give you 60,000 feet squared. For this specific question, it didn't ask you, it just asked for the dimensions. But if the question does ask you for the maximized area, there you go. That is example 2. 1 and 2 are very similar, but 2 is slightly more complicated just because there's an extra width in there. Now we're moving on to another type of question, which is going to involve profit. So there you go. In order to calculate the revenue, you need to use a unit price. Let's say for example, you're selling apples. It's $2 per apple. And the unit sold in this case is just like how many apples. Let's say you sold 10 apples. That's how you know the revenue is $20, right? So there's a quick example. Later, we're also going to be calculating profit because revenue is not your profit. Your profit is actually revenue minus the cost. Revenue is just when you're selling something, how much money did you make on the spot? But that is not the actual profit because typically you actually spent some money to make something or to purchase something and that you're reselling. But in this lesson, for the next example, we're just going to be focusing on the revenue. So let's have a look. Example 3. You have designed a new style of sports bike. Now you want to sell them to make a profit. As the unit price P increases, the number of units sold decreases. The formula is right here. The formula represents the relationship between the unit sold and the unit price. What is the best price to maximize your revenue? Well, in order to calculate the revenue, again, you need a unit price multiplied with a unit sold. In this question, you are already given the representation of the unit sold using the unit price. Well, so we can actually directly use it. That means my R is actually going to be P times S is being represented with P. So 70,000 minus 200 P. There's my function. You're trying to maximize the revenue, so we need to find a maximum point for the vertex again. Let's first simplify, open the parentheses. So R is going to be negative 200 P squared plus 70,000 P. In order to find a maximum value for the revenue, we are going to need to find the unit price first to be able to maximize. So we're going to need negative B over 2A again. Negative, my B is 70,000. 2 times my A is negative 200. So we have negative 70,000 on the top over negative 400. So basically, in other words, you're calculating 700 divided by 4. So it's going to be 175. And don't forget the unit. Actually, since we're calculating unit price, it's dollars, 175. Next, the question is not only asking for the unit price. We just found we just found the P. We now need to find the how many should you sell at the best price. So there are 2 parts of the question. First is asking for the best price. We just found that. Now we need to find the unit sold. So we're going to need to find S, which is given again 70,000, and you're putting it back, subtracting 200 times 170. That is 70,000 minus 35,000, which means the unit sold is going to be 35,000 units. Okay, so there you go. Or you can also call it just bytes since you're selling bytes. If the question does ask you, well, what is the maximized revenue? Well, then you need to use the P times the S. So it's going to be 175 times the 35,000 to give you the actual revenue. In the real world, you will have to take your cost to make the bikes into consideration as well. And in that case, to calculate the profit, you're going to use this to subtract the cost. That's going to be the focus for next lesson. So this is the last example for this second quadratic story problem lesson. Thank you.